Okay, picking up where we left off, somewhere in the vicinity of page 239, because we're talking about stuff that's not really in the book. Talking about distributed databases and how you gotta pick how fault tolerant do you need to be. We've talked about software as a service or database as a service before, and I gave you an example in the last video talking about Microsoft using Microsoft Azure for a database in the cloud. A lot of people are doing this. So that's a very cool example. They talk about the use of other software. So yeah, software that you write typically goes through a database management system. So anything that you write, you're probably not ever going to write your own database. You know, that's just too much work. I'm just going to use somebody else's database, and I'm just going to ask the database to go in and, you know, find that row for me. You know, I'm not crazy. I'm not going to reinvent the wheel. So that's how all that works. Okay. Next thing we're going to talk about, you know, this is it. So, yeah, there's, with other software, I don't know what else to tell you. A front-end piece of software that talks to the database. Okay. The next thing we're going to talk about is big data. Now, you've probably heard this term, big data. But let's talk about what they're really doing. Here's an example of how much data that gets collected. So, I'm at CERN, and I'm using the Large Hadron Collider. And let's look at the amount of data that's being stored, the volume of data. 40 terabytes of data per second. I have to have a database system that can handle that volume of data. Okay. I like the things about YouTube and Facebook. 100 terabytes uploaded per day to Facebook. And YouTube, 48 hours of video updated every minute. That's one heck of a lot of data. So, big data typically talks about, well, let's look at the key terms. The volume. How much data are you dealing with? The velocity. In other words, what's the speed in which the data is coming in? The variety. If it's almost always the same format, you're okay. But perhaps you're getting tons, like YouTube, you know, perhaps you're getting tons and tons of data, but some of it is in this format, some of it is in another format, and perhaps it has to be analyzed and done something different. So, the key to all this, the challenges, is all about either how to store, because it's coming too fast and it's too big, or how to find the stuff, okay? Or perhaps a combination of the two. That's the real challenges is, you know, it's way so much data, and so I either have to find it quickly or be able to store it quickly. Okay. There is another way of thinking about it. This is what's called an in-memory database. Now, in-memory databases are typically going to be smaller. They're certainly not going to be big data because you don't have that kind of money. The idea is instead of storing the database structure in a file on a hard drive, it's all just resident in memory. And, you know, memory is relatively cheap now. You could build an entire database where everything is run in memory, and it'll be, you know, 100 times or 100,000 times faster than the other type of database. Very expensive. But hey, if speed is what you're after, well then by God, this is the way to go. So I've never actually seen one of these, but hey, what the heck, sounds pretty cool. In fact, I'm looking at some of these things going, you know, E-Trade. I'm thinking, really? Okay, fine, whatever. And some of these other organizations that use, you know, all these software packages for in-memory. Okay, kind of cool. The next thing we're going to talk about is data warehouses. It is likely that all the data that you need to do your work is not located all in your database. For example, the story I told you way back when, several videos ago, is let's say that you're McDonald's and you're trying to figure out a location to put your next store. Where do I build my next McDonald's? And so you need information about, you know, sales in every area, but you also need to know, where is there a school being built? What, you have all that data? You have, you know, street maps in your system? Probably not. So most likely that you have some relational databases out there. Perhaps some of these are yours and some of them are not. And you extract data from that. Maybe you got some flat files. Maybe you got some Excel spreadsheets, and you extract all that, and you end up with a data warehouse that temporarily holds all this data for you. Okay. The key to this is this process called a extract, transform, and load. So extracting the data from these big databases, you're transforming them to make it useful for you, and then you're loading it into an honest-to-God database. So extract, transform, and load. So not all the data belongs to you. You're pulling them from other public sources, but you have to physically have them, or not the whole thing. I mean, I don't want to go to the Terra server at the Census Bureau and pull down the entire street map of the entire United States. Maybe I want to zoom in on just a little bit of it and pull down just the parts that I need, right? Okay, cool. So that's how this works. Now, not everyone can afford to have a complete data warehouse. And so there's miniature data warehouses, and they call them data marts. And it's just, I can't imagine there'd be much of a difference between the two other than just scalability. So extracting the data, finding the sources for where all this stuff comes from, and this could be very complex, and it could be lots of things. And doing an extract may take hours to do. Then you have to transform it into something useful, because when you extracted it, you don't really have much of a choice. You're going to get what they're going to give you, and then maybe you can throw in some stuff and convert from metric to English, and all sorts of other transformation that you're doing, and then you load it in your database so it can actually do the query. Okay. Again, a data mart is basically just a smaller one. It could be that your company does this for a living. Let's say, for example, that my company, it collects street data and school locations for a living, and I sell my services to companies like McDonald's. That way McDonald's doesn't have to do that. I'm the one who maintains all the streets, population changes, and school-age children numbers, and where there's high schools are being built, and traffic patterns and street lights and all that. I maintain that in mind, and it's big business for me, and I sell my services to these fast food joints who want to know where to put their next restaurant. Okay, so that's what a data mart is. It's just a tiny piece, perhaps even done by a third party, and you have to pay money. Okay. The next term we're going to talk about is just business intelligence. This is kind of big business. You've probably heard an awful lot about BI. This is where people, remember we talked about data is the most valuable thing that a company has and all that? This is what this is all about. This is a whole bunch of technologies that are designed to allow you to go in and look at your data and make some sense of it. That data to information step, I've got a bunch of data, but I don't understand what it all means. Maybe I need to have some other stuff. So the first technique to talk about is a term called data mining. And in general sense, data mining means there may be some patterns to the data that I just don't see. And there's some software out there that you can run against your database. Now, it could be that the data mining is a built-in feature of your database, like you bought an Oracle or an SQL server, and it has data mining already built in. Or you could buy a third-party data mining tool that you just temporarily attach to your data and let it run. Let me tell you a story. So 10 million years ago, we're looking at the site data for archaeological sites. I know it's kind of a crazy example, but just bear with me. And it has, what type of site and how big it is, and, the distance to a nearest stream, and what its elevation, and which way it's facing. And our question was, is there some sort of pattern here that we're not seeing? And so we got some data mining software and just turned it loose and said, you go find the pattern. We didn't tell it anything, no constraints whatsoever. And what came back was some really bizarre stuff. In our case, the archaeological sites were almost always mapped over a weekend, and so they were recorded the following Monday. All right, that's a bit of the story. It makes a little bit of sense. So the data mining software says, hey, we detected a pattern. 92% of archaeological sites were recorded on Monday. And we're going, okay, that's not very useful, but it is a pattern. So when you turn this thing loose, just don't give it any constraints at all, which is really a stupid idea, but we did it anyway. It's going to try to find out that the vast majority of prehistoric sites are going to be on north-facing slopes. Okay, that's the kind of thing that we're after. Some sort of pattern that we didn't see. All right. So data is all about finding patterns. Okay. There's another one out there. This is not just data mining. There's the other one called online analytical processing. Now, you don't have to be an expert to do data mining. In fact, you can be a complete dunce like we did and just turn it loose, although I wouldn't recommend it. But you don't have to be all that brilliant to be able to make this thing work. On the contrast, when I'm doing online analytical processing, I'm slicing and dicing data, and I'm adding more cube analysis. Perhaps you've heard that term. And here I have to know an awful lot about the industry. I have to know an awful lot about the data in order to make this work. Because if I don't know about the data and I don't know about the industry, well, then this is just kind of crazy. So one is I have to be a pretty good practitioner of the business, and the other is not so much. Okay, so this is kind of sort of near approach. For example, in online, you could say, find all stores within 200 yards of something. You can actually spell it out in English, and it'll translate it behind the scenes and make it do this stuff. Okay, here's a good comparison between the two. So OLAP supports data analysis and decision making. Yeah, okay. Well, data mining kind of sort of does the same thing. This is a top-down, query-driven data analysis. In other words, someone who really knows what's going on is going in there saying, I want to see the relationship between, in other words, I assume that this relationship exists. Now I want to see it. Here it's, I don't have a clue what the relationships are. So I want you to tell me what these. Here's, I know what the patterns are. I'm trying to drag deeper. Here's, I don't have a clue what the pattern is. So here, yeah, you must be very knowledgeable, both of the data and the business. And here, you just say, hey, if I trust my tools, I'm going to let them roll. Okay, cool. Predictive analysis. This is all about, it's really just data mining with an extra twist. Data mining with, you throw in a few rules. It looks at the historical, whatever it is, historical sales, with just a few rules, and it'll try to predict what the next price would be. Now, predictive analysis is used by lots of people, for example, doing stock trades and things like, here's a historical, performance of a stock, and therefore, using a couple little magic formulas, I'm going to assume that the stock's going to be at this point by tomorrow, and thus, therefore, I'm going to buy or sell. It's data mining, just with the extra few little tweaks into it. Data visualization. There could be that your data is so big or so complex that it's difficult to actually visually present it to the user. And so you kind of sort of know what we're talking about. A lot of people use what's called a key performance indicators, KPI. They'll have like a dashboard. And so here's what they see. They log into the system and they're talking about, mobile sales, versus, quarter 2 and quarter 3. And, here's scheduling resources and customers and budgets. In other words, they take this complex piece of data and they simplify it down to something simple that the user can see. And typically, these dashboard applications allow you to click on that. For example, here's the R&D budget. If I click on the R&D budget, it'll drill down. That's a term you probably heard. Drill down and give me more information. I could click on one little piece, it would drill down again and again and again and again. So this is a visualization tour. The picture is worth 1,000 words kind of thing. The next thing you talk about is competitive analysis. And this is kind of tricky because what they're basically talking about is, you can use data as a weapon, so to speak. You can go in and collect data on your own company to help you make good decisions, but you can also collect data on other people's companies to help you make decisions. Okay. And there's counterintelligence going on there where you're trying to make sure that other people don't get to your data in order to make decisions. In other words, if I knew what you were going to price your product at, and I'm a competitor, woohoo, that's some dang good information. Okay, we have reached the end of the chapter, and we'll see you guys again in some future chapter.